Breakout session 2 on day 2 in the technological track. Alistair Stead has been, I don't know, I just got distracted. Alistair Stead has been working in the community for a long time and is well regarded for his high quality work. For example, his Mage test unit testing integration in PHPUnit integration into Magento, amongst others. I was lucky enough to meet him about a month ago in Munich. So at a community hackathon, which was a great joy. So I'm very glad you're here and presenting today on quality assured deliverance. And I'm looking forward to your talk. Thank you. Welcome.
Thanks, Vinay. Thanks for the introduction. Welcome, everybody. My presentation, as Vinay mentioned, is entitled Building Quality with Confidence and Magento. A little bit of background on my story, as it were, is I'm Technical Assurance Manager at Session Digital, a UK-based gold enterprise partner. And we focus on large-scale deployments of Magento Enterprise, technical, complex integrations with back-office systems, and large-scale deployment. So quality assurance really fits into the work we do. The size of our teams, because of the size of our projects, are big and they have many skill sets. So we need tools and processes because quality assurance is about getting stuff done, getting stuff on time, but getting the right things done at the right time and right first time. And ideally exceeding clients' expectations. To do that, we need roles within our teams, we need tools, and we need processes. But with a learning exercise so that we never let the tools get in the way of actually delivering what we need, and we evaluate them at every step. Magento is essentially a complex piece of software. It's large. There's a lot of files. There's a lot of lines of code. Ensuring quality on an application of that size is difficult. No one person can keep track of the base code base, let alone making it bigger by extending it. One of the big problems with building a Magento project is repeatable state. Magento is eminently flexible, but state is managed within the database. The configuration isn't all static files that you can maintain in source code. Some of that's in the database. So when you've got a larger team, you've got lots of configuration to manage and distribute. Does everybody have to do that configuration? Does everybody have to log into the admin, change the settings for the store? Does the phrase "works for me" sound familiar? That's the bane of a team lead's life. Somebody saying something doesn't work for them when it's working for every other person in the team. And you can lose days and days trying to track down that problem. So repeatable state can be the root cause of pretty much every problem in a Magento project. To combat that, we use a number of tools and processes. Starting at the very bottom, we use Vagrant and VirtualBox to virtualize our entire development environment. Not everyone on our team is sysadmins. Not everyone on our team likes to build servers and configure their laptop for the project. So Vagrant allows us to script the creation of a virtual environment on every developer's laptop. They're not working in a central repository. They can be based anywhere. We like our teams together, but it doesn't mean they're always sat in the same room, and they don't all have to be sysadmins. This also helps us negate differences between base operating systems. Some of our devs are Windows guys, some like a Mac, some on PC. If they're all installing different base technology and then Magento on top, there's going to be potential for errors that we won't find until we then deploy to a production environment or a staging environment. And that's probably the last place we should be doing any diagnosis of defects. We use Chef to script the actual configuration of the software, installing Apache, MySQL, Varnish, Redis. All the different technology stack is all handled through Chef. Chef also allows us to migrate that configuration through every stage of deployment, not just on the developers' laptops, but onto the CI server, onto the staging and UAT servers, but also onto production. But our environment's not always stable through a project. The technology we started to use on day one may change as we scale the problems. So we may need to introduce new software. Chef lets us distribute those changes, maintain them in source control, and just push them out to everyone in the project team. But as we mentioned, Magento's a big project. And we're just making that number bigger by adding enhancements. So we need some mechanism of maintaining that, seeing what's happening, seeing how big the code base is. And source control is not new, but we really like Git for that. And GitHub especially, because it gives us another layer of review. Somewhere where a team lead can actually comment on code. In line, saying, you know, I spotted a copy and paste. That's at the bare minimum. But it might be this code could be optimized, this doesn't follow the architecture that we designed and decided upon as a team. Any number of things. But actually seeing it in line with the code, identifying what should be done, makes it really good. Git also allows us to branch really cheaply, really easily. And we advocate branching for every feature, so that the development of one feature doesn't block another, and we can release at any point. So we do have lots of branches. They're developed in isolation, a new feature created, added, branched from development, and merged back in on completion. But what I'd advocate is don't just branch freely. Follow some form of methodology. Git flow was, I believe, mentioned earlier in the week. And there are tools that extend Git that will enforce that workflow. But that's just a helper. It's just using the base functionality of Git, and don't let that get in the way. Use Git as powerful as you can within your team, or use something like GitHub Flow, which is also documented really, really well. And it's just a methodology so that all the team are working in the same direction on the same processes, so that you can pick up and work collaboratively on the code. But if we're making modifications, how do we know they're done? How do we know that my definition of complete is the same as your definition of complete? Because the idea, or ideal scenario, is that when I say something is complete, it's production ready, it's releasable. It's not, well, I've written lots of code, and it kind of works, but I haven't dealt with all the edge cases. So within our teams, we work with a definition of done. At the start of a project, the team will write down what they perceive as done. It's a contractual agreement within the team, and there might be many criteria by which we define a unit of work as complete. But the key element is that it's production ready. So we don't have any surprises at the end of the project that something was 80% finished. It's done. It's ready to merge. But maybe one of the steps we have in there is code review. Code review isn't just about finding problems. It can be a learning exercise. Within our teams, we will have regular code reviews, either from the team leads or the senior engineers, but also group code reading sessions. You know, reading code within a team can either uncover potential mistakes or actually uncover really good things, and the rest of the team learn them all in one go. You don't have to write down how you should do things. You're spreading the knowledge, and everybody's learning as they're reading essentially the code that the team have produced. So we've had a review, we've finished the feature, but now we need to start building a release. And one of the key members of our teams is the release manager. They're the one person that gets to decide what's ready to move forward into a production environment. And by having separate branches for each feature, we're never blocked. If a client needs a release tomorrow, next week, the week after, we can already tell them what's ready to be deployed straight away. And by ready, it's done, and we know what that means. On top of that, manual code review and release management, we also implement a lot of static code analysis. And static code analysis can be quite cumbersome to start with. New developers find it quite tiresome to be, fixing lots of warnings and defects. But actually in practice, within a project, it can be a real lifesaver. PHP Code Sniffer, for example, all it's doing is syntax checking and code standards adoption. So if you pick a code standard, such as the Zen standard, which Magento has adopted internally, it actually means that every person in the team can just skim the code and decide exactly what the logic should be without any confusion. A simple matter of keeping the line length so that it fits on one window without breaking means that logic problems tend not to occur. An if statement is the simplest thing in the world to implement, but if it takes 2 lines, you have no idea what it's doing. Cyclomatic complexity is something we also analyse. If you studied computer science or read any of Martin Fowler's books, he quite regularly suggests that methods should have a maximum length. Strictly, it's actually quite low. Recommendations are around, a method should be no longer than 5 lines. We're a little bit more relaxed than that. We're more looking at cyclomatic complexity. How many paths through your code are there? The more paths there are, the harder it is to evaluate, the harder it is to maintain, and the harder it is to change how it currently functions to match how you now need it to function. Anyone can write code that works. Good developers write code that's simple to understand and extend. And by measuring cyclomatic complexity, we start to get a pointer as to whether our teams are maybe heading in the right or the wrong direction. We're not really strict. It doesn't have to adhere to these numbers, but it has to be in a positive trend. We're working to quite quick deadlines. We want a quick turnaround. But if the graph of complexity is going exponentially in the wrong direction, we know we've got a project that is really difficult to maintain over time. If it's in a positive trend, we know we're doing good. And any of the developers on our team are always looking to improve any file or line of code that they look at any time. We do implement testing. We do test-driven development. As Vinay mentioned, internally we created the Mage test framework, which extends PHPUnit. But we have a culture internally within the team that we write tests. We write tests as we write code, not necessarily before we write code, but we have a philosophy of going home green. If your tests are failing, you're not going home. Now, we're not really that strict, but we have a cultural bias to ideally go home green. You don't feel good about yourself if you're going home with tests that fail. Because someone else on the team will pick up those failing tests and probably poke fun at you. Mage test gives us all the tools we need for testing the code at a unit level. You can also mock controllers and check that the HTML being returned to you is valid and correct, and make assertions against that in the same way you can with Zen Framework and Zen Test. That's only part of it for us. Testing the unit of code helps our developers get to the final answer probably quicker than they would without it, because they have to separate the code. They have to isolate the code they're writing from the core of Magento, but also from other parts of the code. So that by testing it, you're forced to isolate it, to decouple that code. But we also see behavioural testing of the application itself as kind of key to our delivery. Because a unit of code might do what the unit of code should do. But we have customers who are trying to purchase products through our stores, and the key thing for them is not whether the code is functional and elegant, it's whether they can buy a product and whether the feature works for them. So behavioural testing inverts the focus of testing back onto the behaviour of the application. And we can make assertions that are simple yes or no. Acceptance criteria that say, if this feature does X, then it's correct and it's successful. And in these scenarios, it should be a negative response. So we actually write our initial specification for a project as a definition by example. This is actually Gherkin syntax, so anyone that's worked with Cucumber and Ruby, this may look familiar. But there are tools with PHP, and there will be shortly a release of Mage Test that also integrates with these tools to allow you to write definition by example that will either test Magento directly through the controller, but also through browsers. The tools that we use are Behat and Mink. These are all PHP tools, they're all open source. Behat is a BDD framework, and Mink is an adapter to most of the common automated browser testing tools, such as WebDriver or Sahi. And those allow you to run true user tests, testing JavaScript and every element of functionality on your page very, very quickly, and identify whether things are working as they should, and then more importantly later on, still working after subsequent modification. So we've got loads of mechanisms for looking at our code, inspecting it, testing it. That's a lot of overhead that our teams really don't have time to look after. So we have a continuous integration server. Our continuous integration server is called Jenkins. He's quite common. Lots and lots of people use Jenkins, but we use an install of Jenkins for every single project that we have. And Jenkins is there to monitor the progress of the team. Do things still work? Do they match all the criteria that we set in our specification? And are all the code metrics by which we're measuring the performance of the team still in a positive trend? And if they're not, if someone broke the build, or if the thresholds aren't being met, Jenkins will alert the team and also point fingers at people that broke things, which can be amusing at times, but not when it's me. Jenkins is simply configured using Ant. It's just XML. If you're using Magento, you're pretty happy with XML. So Ant's really helpful for configuring the CI server, creating build tasks that potentially do more than just the testing. Potentially doing the merge of CSS, ready for deployment to Amazon CloudFront, as we saw yesterday from AOE Media. So we've got lots of tools there to help us ensure quality, ensure valid and accurate code implementation from the team, but we haven't addressed some elements of application state. As I mentioned, a lot of Magento's content and configuration is held in the database, as you would expect. So we've got content, we've got application configuration. If we've got a team of 5 people, do all 5 people have to set up the homepage? Do all 5 people have to configure the support email address for the store in order to test it? And that's a development team. What if we have a CI server, a UAT server, a production server? Do we have to do it on those as well, with each deployment? Here we use Magento's already pre-built upgrade hooks. So we create a core module for every project, and within that core module we'll maintain a revision, and each revision will include a setup script that maintains everything about that store. So any developer joining the team doesn't have to log into the admin system. In fact, we advocate that the developers never log into the admin system, because if they're doing that, they've skipped a step, and they're probably doing something that will be lost between the rest of their team. So they're always creating setup scripts. Occasionally we have a maintenance task to merge them, but what we aim for is to be able to go from bare metal to a project configured exactly how we want it in approximately 15 minutes. And that's achievable using all of the tools and the processes that we've addressed so far. But then we're ready to deploy. Now there's many tools out there for deployment. They can be simple, they can be complex. Our preferred mechanism is Capistrano, which again is a tool from the Ruby world, but we really like to pull in the best of breed tools to solve the problems. We don't want to recreate tools. We want to use what's there and leverage the work of others in the open source community. So Capistrano really is the right tool for what we do right now. It may not always be, but for right now, it's really good. And to make it easy for everybody else, we created Magentify, which is an extended version of Capistrano, pre-configured with all of the tasks and tools and configuration relevant to Magento deployments. It's also easily extensible. It's open source. It's on GitHub. You know, I think quite a few, a couple of people in the community have already trialed this quite successfully. But what that allows us to do is to deploy to one or many servers at the push of a button. And it's scripted, so everything is automated. There's no manual steps. So we can actually set up a deployment pipeline, as it were, or a flow between development and production. So in our case, we will have at least 4 steps. We'll have the development servers or on the developers' laptops. We'll have a CI server where all the developers' work is integrated. And we can do testing there, manual testing or automated testing. Then we'll have a UAT server where potentially that's where the client will start to see the work. They'll start to sign off the progress and accept the functionality that we've created. And then we'll deploy to production. One word on that is no matter how big the pressure, no matter how tight the deadline, don't shortcut that process and test in every environment. As much as Capistrano and Magentify provide functionality to roll back releases, test in every environment. If you're in the position where something's gone wrong on production, yes, roll back, but don't diagnose a problem on production. Don't diagnose a problem on UAT or on the CI server. The problem should be repeatable on the development environment, because if it's not repeatable in the development environment, you've got a state problem, which means processes and tools aren't working for you. We ideally work towards zero downtime deployment. That means we can push the button at any time of day to deploy our code. That's an ideal. Don't do it when you've got 5,000 users on your site. But it's an ideal. We're in a position where we can press deploy, but ideally check how many users there are. So, if we have a quick recap, we're working on complex projects, which means we've got many people. Because we've got many people, we need clear requirements. Specification by example solves that. Having many tests means we can feel confident that what we've produced is of the right quality, the right standard, and meets requirements, meets specification. Because we've got automated tools for deployment and there's no manual steps, we can do many deployments, anytime, by anybody on the team. No one person has to remember to turn off a service, move a file out of the way, FTP some files, move them back. Anybody on the team can do that. And the goal is zero defects. All of those processes are working towards zero defects. But we evaluate and improve at every release. Both the tools, our processes, the way we're constructing projects, the way we're constructing our teams. Over the last 12 months, we've made many changes, including all our projects having a dedicated testing resource, so one person who's solely responsible for testing the work of 4 other developers. But they're not just testing, they're also involved in specifying how things should work, because they're working with the client to write that specification by example that then the developers can understand very clearly and make sure they deliver the right thing, the right time, first time. So that brings me to the end of my presentation, which was probably a lot of buzzword bingo, but hopefully it's an insight into our processes, our tools, and our flow. Does anybody have any questions?